Hello everyone. Welcome to the fourth session of day one. I am Dr. Gaurav Kumar Patro. I am a research scientist at Phi Labs Quantiphi. We'll be talking about responsible AI in the era of generative AI and how Quantify is approaching this goal for enterprise AI solutions. Here are the team members. Along with me, Himansu, Supriya, Nim, and Visal, who have contributed to Quantify's responsible AI initiatives across research, innovation, awareness, implementation, consulting, and compliance. Today, Himansu and I'll be presenting some of our team's recent work. We'll be starting with a recap of responsible AI principles that are embedded into Quantify's policy and briefly discuss various initiatives taken along responsible AI compliance, innovation, and consulting at Quantify. Then we'll be discussing our novel C square V square framework as a standardized approach to design responsible general purpose and agentic systems. Finally, before moving to take audience questions, we'll cover Quantify's approach to responsible AI policy and risk management, especially in the context of enterprise AI governance. Now I'll hand it over to Himansu to discuss responsible AI at Quantify and also our novel C square V square framework for agentic and general purpose AI systems. Over to you, Himansu.
Thanks, Gaurav. Hello, everyone. I'm Himanshu Garat, a senior machine learning engineer at Quantify, and I'll provide an overview of our approach towards responsible AI. Now, while AI has been growing rapidly and transforming the way we work and live, it also brings in risks, and responsible AI is all about addressing those risks so that AI remains trustworthy, ethical, and truly benefits the society. Realizing the importance of responsible AI, we began our journey to make it a core part of how we develop and work with AI. And here's a quick recap of how the journey has unfolded since then. At the center of our approach are these 8 core responsible AI principles that help us translate big ideas about responsibility into everyday practice. Moving forward, we have been advancing responsible AI into 3 focus areas: compliance, innovation, and consulting. To sum up, compliance covers responsible AI practices end to end from design, development, deployment, and to use. And this is paired with awareness training programs as well as aligning with global standards like the NIST AI RMF or the EU AI Act. Next, innovation is about driving responsible AI into new frontiers, whether it's identifying emerging risks or developing new approaches to address them, as well as to even shape them into opportunities. Finally, in terms of consulting, we extend our support through risk assessments, audits, and governance reviews, as well as technical guidance to understand the risks, navigate frameworks, and put the right safeguards in place. As we move towards ensuring compliance by identifying and addressing risks, we have Ethic, which is our impact assessment tool designed to evaluate AI systems for ethical risks. It starts with sensitive use case analysis, helping projects to identify potential legal and ethical consequences. And then, depending upon the sensitivity of the use case, it extends to a comprehensive questionnaire enabling holistic evaluation and also provides a risk score to quickly assess the level of risk. Then it also offers mitigation strategies to provide actionable insights or recommendations to address the risks that are identified. And this is followed by a multidisciplinary REI committee review for medium and high risk projects to bring diverse set of expertise to validate the risks as well as recommendations and to add depth as well as rigor to the entire process. Now we turn to what responsible AI means in context of general purpose AI or GPI. With GPI shaping more aspects of work and life, we believe that its ability to impact many domains at once makes it critical to get responsible AI right. So earlier we had AI systems which were mostly task specific, built for narrow predefined problems. But now with GPI, we are dealing with systems that can do much more. So characteristics like adaptability and versatility have accelerated the uptake of GPI. And because GPI is no longer confined to a specific task, it brings newer risks in terms of hallucinations, toxicity, stereotypes, etc. And as these risks grow, its use in critical sectors such as healthcare, recruitment, finance, etc., brings high stakes. So, together, these trends highlight why advancing responsible AI for GPI is essential. Now, in our approach to achieve responsible GPI, we begin by classifying AI systems into two broad categories: type 1 AI systems or task specific AI systems, and type 2 AI systems or GPI systems. Type 1 task specific AI systems were typically designed for narrow predefined problems, and they followed structured fixed format outputs. While they had limited risks, they did not have characteristics such as flexibility and adaptability. Now, in contrast, type 2 AI systems or GPI systems, they do offer adaptability and flexibility, but they not only amplify the existing risks, they also introduce newer risks in terms of hallucinations, misuse, toxicity, stereotypes, etc. Now, in the example below, we can see that in case of recruitment, there are multiple tasks needed to be accomplished to achieve a goal. And the earlier Type 1 AI systems had a task specific model for each stage. But through GPI, it can be achieved using a single LLM based systems, which in itself can perform a range of tasks. So to address the challenges of responsible AI for GPI, we design a C square V square approach and formulate that responsible GPI demands desiderata in the form of control, consistency, value, and veracity. To begin with control, we believe that a modern GPI system should have control over when, how, and which optimization technique, model, or precision to choose, which can address sustainability concerns to some extent. Then control over outputs can help mitigate privacy risk by preventing unintentional or sensitive data leakage. Also, avoiding responses to adversarial queries can prevent uh, safety concerns such as unsafe, illegal, or toxic outputs. Additionally, an overall control mechanism can improve governance. Next, we move to consistency, which directly strengthens robustness by ensuring that small variations in input do not cause unpredictable changes in output. Additionally, it can also enhance reasoning processes and enhance the faithfulness of explanations. Next, we move to value, and we believe that modern GPS system should have its own value system where there could be values such as equality, inclusivity, or non discrimination that can address fairness risks. Additionally, values such as confidentiality, data minimization, or purpose limitation can help with privacy risks. Then it also addresses governance by ensuring that AI systems are accountable for their actions. Finally, we move to veracity, and we believe that a modern GPI system should have veracity of facts and evidences to address truthfulness as well as out of distribution robustness concerns. And this can ensure outputs are grounded in reliable sources. Moreover, it can support faithfulness of explanations by ensuring that the explanations reflect models' actual reasoning processes. So together, this framework can be used to identify the RAI requirements and then map them to the desiderata. Next, we use techniques that are embedded within the system architecture to fulfill these requirements. Talking about techniques, here are some of the examples of the techniques that can be used to meet the RAI requirements. Again, the list just goes on. For instance, we can have retrieval augmented generation or RAG, which improves generative AI by incorporating external resources into the system's reasoning and response generation. So this improves consistency and veracity. Similarly, guardrails, which are enforced set of predefined rules, provide a degree of control while also help to check values and veracity of a system's response. Then again, this list is non-exhaustive, where there could be many more techniques that can be mapped to the desiderata and therefore uh, help us meet the requirements. Now let's try to understand how we can operationalize the C square V square approach using the same recruitment example that we just saw earlier. Now step one is to consider all domain specific and application specific settings and concerns. In this case, for stage one or candidate sourcing, the concerns could be stereotypes which reinforce gendered or role specific biases. Then there could be disparagement, which excludes or devalues certain groups. When we move to stage two or resume screening, there could be concerns such as stereotypes, where LLMs can infer skills or traits based on demographic signals, as well as there could be hallucinations, where LLMs fail incomplete resumes with fabricated skills. When we move to stage three or initial assessment, there could be concerns such as OOD language or OOD style, where there could be unfamiliar vocabulary or non-linear ways of answering a question that can be treated as incoherent or incorrect. Finally, in the decision making stage, there could be risks such as stereotypes, where there can be assumptions based on demographic signals. There could be hallucinations, where LLMs can generate misleading comparisons or rankings. And finally, there could be toxicity in feedback or judgments. Having identified the concerns, the next step is to outline the RAI requirements and map them to the C square V square desiderata. So some examples of requirements here could be to enforce filters for toxic or discriminatory language, which maps to control. Then one of the requirement could be to ensure inclusivity in job ads, which maps to value. Another requirement could be to check that the summaries map or match the original resumes, which maps to veracity. Once we have identified or outlined all the RAI requirements, the next step is to identify the techniques that we can use to meet the requirements. So some examples here could be guardrails, which are mapped to control and value. So they prevent toxic or discriminatory language and check for values such as inclusivity, diversity to meet requirements related to fairness, and then also address safety. Similarly, self verification could be another technique which maps to veracity, and it helps in ensuring that the summaries match the original resumes, which will reduce hallucinations and ensure truthfulness. So we list down all the techniques that can be used to meet the RAI requirements, and then we finally put them together as a system with additional feedback and control mechanisms to achieve true responsible GPI system. So this in all summarizes our approach towards ensuring and accomplishing responsible GPI. Now I'll pass it on to Gaurav for further details on enterprise AI governance.
Thanks, Himanshu. Now we'll move on to enterprise AI governance. AI risk plays a key role in organizational AI governance. Effective AI governance requires efficient management of resources and responsibilities to monitor, measure, and mitigate AI risks. There exists a number of challenges in organizational AI governance. One of the major challenges is the complexity of risk measurement. Modern AI risks like jailbreak and hallucinations in LLMs are often context, dataset, and metric dependent. Additionally, latent and emergent risks, for example, consequential negative impact of over reliance on LLMs, is often understood only in real world settings, not in lab settings. Second major challenge is in understanding and adapting to varied and evolving risk tolerance levels. This is often due to shifting of social and legal norms. Another challenge in organizational AI governance is how to prioritize particular risks and allocate resources for handling and mitigating them. For example, in an LLM based educational application for children, the, the risks of toxicity or age inappropriate or unsafe content can be of more priority than the risks of prompt injection. Finally, for an effective AI governance, organizations need to tackle challenges of AI observability throughout AI's lifecycle and accountability through defined roles and responsibilities. Considering all these challenges, an organizational AI policy should answer a number of open questions. Here are some important open questions across compliance, assessment, training, enablement, and enforcement. With regards to compliance, which regional, country, or industry specific regulations should the AI application be compliant with? Are there any other or additional context or technology specific compliance requirements? What are the transparency requirements in terms of documentation and reporting? These all questions need to be answered with respect to compliance. Similarly, for assessment, the policy should answer which AI risks need to be evaluated for, which use case, and which tech stack is actually relevant to those risks. What are the organizational, economic, and legal impacts of these AI risks? How should these AI risks be mitigated? All these questions are also relevant. Now, for training and awareness, which programs should be adopted for the staff? Whether the staff need to be attending all these training programs mandatorily or it should be optional. Which team need to be trained on these RAI policies and training? How often should the training programs be updated? Again, these are the questions on training. Now coming to RAI enablement. What kind of technical assistance, tools, and artifacts should be made available to the teams to ensure RAI compliance? How should the leadership be involved in this? Now, with respect to enforcement, who should make and enforce the RAI policy? Who is in charge of supervising and reviewing the enforcement? And how often should a revision take place using organizational feedback? Now, all these questions are open questions, but these questions need to be answered in AI governance policy. Therefore, to answer these questions, one needs to provide a strong risk management framework. An AI risk management framework is a structured approach to help organizations manage risks across AI lifecycle, ensuring AI systems are trustworthy, safe, and aligned with organizational values. It addresses various AI governance challenges through cross-functional AI lifecycle management, standardized and exhaustive AI risk mapping, measurement and mitigation methods, clear roles and responsibilities with accountability and instructions for continuous monitoring and reporting measures. In this regard, Quantify follows the guidelines provided by NIST, National Institute of Standards and Technology. Let's go into what NIST RMF actually supervises. NIST RMF provides guidelines for organizations on how to manage AI risks throughout AI lifecycle. It suggests four core functions: govern, map, measure, and manage. Govern function essentially deals with setting up policies, defining roles and responsibilities with respect to other core functions, right? Like map, measure, manage. Map function is for understanding AI system, its purpose, functionality, inputs and outputs, potential risks, and stakeholders. Measure function emphasizes the evaluation of the likelihood, occurrence, and impact of identified risks. And then finally, manage function involves implementation of risk mitigation measures. While govern function takes care of the policy making part and enforcement part, map, measure, and manage. These functions provide technical and functional guidance on continuous AI risk management. Following the NIST RMF's recommendation, Quantify's efforts towards enterprise AI governance can be grouped into six building blocks. With regards to compliance, apart from the regional regulations like EU AI Act and GDPR, Quantify strives to comply with internal RAI policies like fairness, robustness, safety, transparency, and privacy. As part of assessment, Quantify follows comprehensive AI risk assessment for all incoming AI projects, performs risk scoring, and also periodic AI audits in sensitive use cases. Various internal training and awareness programs run within Quantify to ensure staff are trained on responsible AI practices. As part of enablement, our AI risk assessment tool called Ethic plays an important role. For enforcement and governance, we employ various project and risk reviews, some involving multi-stakeholder committees like REI committee. The responsible AI team has also collaborated with internal teams and external clients to help on risk assessment, mitigation, and also various RAI requirements on AI bias, fairness, and explainability. Now, this brings us to the end of the session. Thank you.
Thank you so much, Dr. Gaurav and Himanshu, for that wonderful session on responsible AI in the era of Gen AI. We have a bunch of questions, so without any further ado, let's quickly go into them. So first up, we have a question from Saurik. So we understand C2V2 and what all requirements of GPAI, general purpose AI, it includes, but how are these requirements exactly met? If Gaurav, if you would like to take that up, yeah, please.
Yeah, that's a good question actually. Uh, so our C square V square framework covers actually majority of the RAI requirements which are important to mitigate today's AI risks, which are mostly known or known to some extent. Now, the benefits of C square V square in enterprise setting is actually in standardizing the approach to responsible design, development, and also deployment of AI systems. So, which is often overlooked when we think about responsible AI. Now, it exactly contributes to thinking about various orthogonal RAI requirements, which might be fairness and robustness, right? And these might be different for different use cases. So, if you take an example, let's say you talk about conversational agent. Now, a general conversational agent might be able to or should be expected to answer more questions or more questions in the sense various domains and fields. But if you talk about conversational agent, which is deployed in educational platform, let's say for children, okay, you wouldn't want the agent to answer questions which are sensitive and maybe not appropriate for children, right? Now, in that sense, control the pillar of control in C square V square that actually standardizes the process and gives the designer of these AI systems to take a look into that, right? So I hope the answer is clear.
Thank you very much, Dr. Gaurav. We have a question from Gopi. How and where does the RAI framework integrate or get enforced? Is it mandatory or aspirational with multi-agentic flows using large language models or smaller language models in routing, etc.? And how does this handle AI-generated misinformation such as deepfakes, etc.? Yeah. Gaurav,
Yeah,
would you like to take that up? Yeah,
yeah,
please
yeah,
go on.
let's come to the first part of the question. How and where this REA framework integrate and get enforced? So yeah, again, coming to the motivation behind C square V square, this is exactly to enforce a standardization for designing AI systems in enterprise settings. Now, coming to RAA framework to integrate, let's say legislative compliance, or let's say compliance with respect to a particular organizational requirement, right? So, for example, Microsoft might have different organizational requirement for compliance, or let's say the application is being deployed in the EU, then European Union will have that legislative compliance requirement, right? Now, those are already taken care of in this framework when we talk about control, right? And when we talk about value, most of the requirements like bias and non-discrimination are actually being covered, right? Now, coming to the next part of the question, with multi-agentic flows and LLMs and SLMs also routing, how does this handle AI-generated misinformation and deepfakes? So again, misinformation is actually something which we try to cover in control. When we say that, okay, how do we want the LLM to respond, or what kind of things are actually not expected from the LLM or the system, we try to ensure that this doesn't happen through that, right? And then we have these guardrails which sort of take care of these misinformation related issues. Now, coming to deepfakes, is a case of misuse. Now, uh, if it is a case of misuse, then we do need to have accountability mechanisms, which are again part of the value pillar in the organizational setting, to ensure that the system that you're deploying or allowing the user to make use of, they don't get misused, right? So I hope this is answered. Yes.
Yeah, thank you, Dr. Gaurav. We have another interesting question. So what ethical risks are most overlooked in general purpose AI from Ganesh? Himanshu, would you like to take that up? Yeah, please.
Yeah, sure, Varun. So, while for LLMs, we often deploy various guardrails to ensure uh, safety and trustworthiness. However, when these LLMs are used in more complex tasks, which involve static and dynamic workflows and interactions with external tools or systems in general purpose AI, the risks like subtle bias amplification, privacy leakage, which can be through prompt injection, and the downstream misuse in unintended context, they are the ones which often get overlooked. And when a model which is built for general purpose, like let's say text generation, is later adopted for some sensitive settings such as recruitment or medical advice, uh, and if it doesn't have the adequate safeguards, then the system is not really a secure one. The original developers may not anticipate the high stakes of the application, but the risks such as discrimination, misinformation, or let's say harmful decision making, they emerge once the model is uh, repurposed for the downstream application. So these are the risks that are most overlooked when it comes to leveraging GPAI for the downstream tasks.
Thank you. Thank you very much, Himanshu. I think we have covered the bulk of the questions. So in the interest of time, we'll be taking up the other questions offline. So thank you very much once again, Himanshu and Dr. Gaurav, for that wonderful session on responsible AI.